cardiac rhythm analysis as well as measurement in zebrafish larva video datasets. As I am Ali Farhan from Pakistan and I am currently PhD fellow at Chung-Der Christian University under kind supervision of Professor Chung-Der. So our basic concept regarding this approach is based on the automatic detection of the cardiac rhythm and from the video datasets, and we used simple OpenCV library and modules and the Python programming language. So basic introduction included in this extent that we have already some AI approaches that already developed for the cardiac rhythm analysis like face detection and other rhythm analysis for the humans. So our purpose of developing this approach was that we have to concern about the extent that most of the time we have manual a method for the cardiac rhythm analysis, and our lab previously developed simple manual method as ImageJ. So that was very tedious and time taking. So to overcome the limitations of the manual analysis method, we introduced this approach in this extent. So basically OpenCV library is the core concept behind this that we used, and all of the expert user regarding Python programming language and other, they must know about the viability and the as well as the deep extent that how OpenCV can help out in video recording analysis and the 2D dimensional extent. And also we use some multi-processing aspect in the Python language that you can select the atrium and ventricle region for the zebrafish in the video so that you can easily detect the heart rate of the two different chambers. And the finally we validated our results, our previously developed method as ImageJ. So we can see that our results were almost equally uh, good as ImageJ performed. So basically the setup for this automatic cardiac rhythm detection system, that you have to record the 2D video that we have set up in our lab is high speed CCD. Installation of Python 3.8 or above version. The other versions can also work, but most recommended is 3.8 and above. And then you can download the essential computer vision packages as you can see based on related to the OpenCV, that I will introduce some commands that we commonly use in this concept. So then you have video that is in MP4 format. So MP4 format is mostly recognized as well as mostly practicing format in most of the cardiac analysis videos, as well as it's commonly available in downloadable form, so you can always easy to use to transform as well as to use for the analysis in MP4 format. Then you can run the program by selecting ROI for the atrium and ventricle and then analyze the data and the result presentation. So these are the basic steps that you can follow the program extent. This is our video recording system that you can see the high speed video recording system as high best viewer. You can see that resolution, exposure time, auto shoot speed, record frame and preview and the trigger stop. So resolution that I uh, can see that we have the size of the video taken in the linear correlation that exposed, and then exposure time that we have to integrate for the extent of the sensor within the light. The auto shoot speed, recording frame that mostly we select for this is the 200 frame. Here you can see it's mentioned as 200. We did set. Then record the frame, and after you can see that previewing the result, and then you can trigger to save the video. And the steps initialized in program that we developed is that put MP4 format in the desired location or folder of the system that we created, and download I mentioned earlier Python version mostly 3.8, and then name of the folder as per desired on the user, depends upon the user. And now the concept that you can see that here is the folder that make as title of the video for test.mp4. This is in the case when you are not using the GUI concept. So it's basically the purpose of this tutorial is to share the extent of our program that you can use coldly even the GUI is not available. So this is basically open command prompt window program that you can see. You do not have to use any kind of anaconda or like that, and it can easily be run in an average CPU like our Core i3, Core 7 in currently era we are using. Not specifically GPU is not required. The commands to install the libraries for this program is the you can see the pip install pass and pip install imultis and others OpenCV and install SciPy, NumPy, Matplotlib, Mapanda, Scidets and Flow. So here is the basic command window where you can see how we used to install these libraries for the program. This is our basic and simplified flowchart for the non-expert user that how they can use our program for the core extent of purpose that they have to analyze the cardiac rhythm in the video dataset. So simply you have to create the folder that contain the Python file, the package, and then you also know about the downloading of the Python version. Then you can open the command prompt window and then copy and paste the path from the folder in the desired command window. Use the command line to run the program, and then you will see the message that will expect to select the respective region of interest. In this case, as I mentioned earlier, there are two ROIs for the atrium and ventricle of the zebrafish. You can see here is the OpenCV object.py Python file. This is our basic code file, and this is our video file as MP4 format. So these are the two files that you have your folder to run the program, and then you have to copy and paste the path of the folder where you did place the video. And you can see here this is simple, you just have to copy and paste here by using command line. And this step is only in the case as I mentioned earlier when UI is not available. So you can see here you can copy and paste here and you will be easily able to run the program. This is the message box that you will see to select the region with the procedure for the extended first and second. So select the first region as when press enter, and simultaneously you will show another message for the second region right for the cause of the analysis of ventricle part. So you will see similar message box for this. By selecting ROI in Zebrafish Heart, this is our clear vision that you can see that ventricle and atrium is position, and we record the videos of the zebrafish larva usually on this position. In the concern of the lateral extent, we can see that it's on placed on the right hand side by the person who is viewing. And here is the ROI selection for the ventricle, and here is the ROI selection for the atrium. And it's important factor that I must mention here that tool cannot predict or select the ROI automatically. The only step is the manual incorporation is the selection of the ROI by the user, that he or she must know about the exact location of the atrium and ventricle in the given video dataset. So it will be easy and also conventionally more uh, viable that if you select the ROI as compared to other automatic method that previously developed, and they also use some deep learning and the mass. So this is important that you have to select the right ROI because tool cannot select ROI by itself, and most of the time if you look at the studies that previously developed, are the base of some masking and deep learning approaches, they are using automatically selection of the ROI. And most of the time, in my experience, I'm not challenging, but in my experience, that were compromised results, because the automatic selection, the major limitation is the tool will detect based on the pixel or the brightness of the video quality, and most of the time they select wrong area where the atrium and ventricle exists. So this was also a challenging part for us, that like we have to select the ROI that is purely based on the position for the atrium and ventricle in the fish. So these are the two window bars or the windows. You can see that one is for the result one for the first area, and this is the result two for the second area. And here is you can see the success message show that your program is executing accurately. Similarly, the calculation of the rhythm that we used on the basis of 260 fps frame per second as example. The purpose of presenting script here, that you have to understand easily, and also the users can implement or somehow get idea for their own data sets or their own development. That you can see the atrium and ventricle for the variables defined functions are called for the video selection, and the inverse peaks for the interval 1 and interval 2. So basically the interval 1 and interval 2 based on the AVVA as the cardiac endpoints included for this, that automatically it will be shown in the CSV format. So for the cardiac endpoints, interval 1 and interval 2, we used its similar concept that is previously developed in our ImageJ based method that was manual. So calculating on the basis of that, you can see that here is 0.005 is representing that if you have 200 fps video, so you can easily get the 1 frame per second rate as the 1 divided by 200, you will get the 0.005. Similarly for 60 fps video, 1 divided by 60, 0.1016 second. So this is basic and simple formula behind this for frame to frame reading, that how it works, and you can easily get the atrium and ventricle heart rate for the zebrafish larva. And the practice involved in this is simple based on our convention, and as well as the video screening was performed on the correlation algorithm, that you base on the covariance, that step by step and easily adjacent for the next frame it was computed in the video, and you can see that frame values are executing based on our this formula. And also it's validated already our published and the developed method image. Here is the raw data waveform pattern that you can see. Here is the concept that peaks detected display as raw data with number of frames. Here blue for the atrium and red for the ventricle, you can see here. So by applying some spline interpolation, the smoothing were performed for the processed data waveform. Here you can see 200 2000 frame. So 200 into 10 second, you can see 2000 frames. So the one limitation I would mention here, the video data set must have more than 10 seconds, because in elongation time, that actually we record video by high best view 10 seconds. So we elongate it for the analysis about 1.6 second, 1.6 minute, it's about 66 seconds. So for the 66 seconds, you can see that if you multiply about 200 frames for the 10 seconds and then elongate it for that, and for the 1.5 minute, so it becomes into 30 fps. The 200 fps video, we converted for that elongation as 30 fps. And the concept behind this for the calculation, that we used original video as 200 fps, so 200 multiplied by 10, you can see here the 2000 frames. So ye is the peak selection, that peaks of the and the data plots for the good understanding that how it works for the cardiac analysis. Smoothing of the waveform, that is major and core part for the peaks valuation, comprising data validation for that, as well as in most of the cases of cardiac rhythm, peaks are the major, you can say, the part for the analysis and the understanding. So by using simple Python scipy module, some call scipy, but it's scipy module, as interpolate, This is interpolation is a developed module in the OpenCV and SciPy related that grid data function, and then here is the choice that cubic or linear for the extent of the grid. So we used is in concern of cubic, that is mostly applied in studies for the analysis. So we have 2D data as two-dimensional video, and we introduced some float optional, and then could apply some cleft torture 2D interpolator function that is core for the suppline interpolation, and that can show the better and good peaks in for concern of the understanding. Similarly, some of the functions are presented here in concern of, you can say, the calling as xy, because they always two-dimensional video based on xy plots. So evaluating that in the supplying it use for the specific position, and then the supplying at the specific points as I is the specific point. Similarly, spline coefficients, get coefficient function use, get nodes that use for the tuple as the supplying relation with the respect of x and y variable, and some get residual and also integral function are being used for the approximation and supplying residual to for the x and y axis. As the logic design I have to share is to develop the extent that how you people can understand about the atrium and ventricle part for the cardiac analysis and function used, and some of the easy title we use that generally understanding for the time list and the length for the atrium and ventricle for the cardiac rhythm. So you can see that here is the time length managed by the function to extract for the ventricle differences. Basically, it's presented. This is course correlation value set we used for the positive one as -1 -1, positive one, that is interval defined, and then frame by frame it was reading and the peaks will be concluded. This is the logic design continuation. This is the already mentioned in the SciPy link. I also mentioned in next slide, where you can find about the concern that how it works. The purpose of sharing these slides or this part is to for the users who can like, or you can approach the concept for their own data set or for their own analysis, and most of the time the optimal values may differ, so it's better to concern about the specific article and the specific page for the Python scripting. As well as you can see here I mentioned the source where you can see about how this interpolation can work and you can perform. Finalize data plots available, and you can see that final data plots based on as our xy values for the degrees, and matplotlib is the major library for this we used. And there are some concepts also we have to share about the bivariant spline. These are different types of spline interpolation that are available on the website, so you can see about that the how classes can work and how the libraries are working and how the modules are integrated for that. It part of the like the grid subplots and plotting for the title and the grid, and as well as the legends and the representation for the good analysis of the peaks. Here you can see the linear cubic, so I used the nearest neighboring concern of the cubic side. So you can see that it's very easy that if you have a minute or the little knowledge about some peak selection or the some peak detection, then you can apply interpolation by yourself and can work good. So types also I mentioned here, so then you can that simply image show function used to show the image, and then the whole results will be generated. And for the figures you can see that I will mention later about the storing and the saving univariant spline. As I mentioned, you can get much more information about that on the website available for the Python. And this was used on the 1D, so we applied same concept for the 2D, and the modified script according for our labeling as atrium and ventricle. You can see the BO representing the blue color for the atrium, and similarly red for the ventricle, that you can see how peaks are exhibited for the atrium and ventricle part as red and blue. And then you can see the display of the function finally. Here are the simple way. Finally you can see the display filter data available, that how it works. And you can see that I mentioned earlier for the blue atrium and the red color ventricle, and labeling performed for the good understanding. So easily you can perform the legend by the using legend function in that aspect. So this is the smoothing final peaks that you can see very beautifully. We created about that how it works, and for the 2000 frames clearly visible for the atrium, high peaks of the atrium, low peaks of the atrium, high peaks of the ventricle, low peaks of the ventricle. You can see here high peaks, low peaks, high peaks, low peaks, so are marked. So this is the basic concept of the smoothing that you can see. It's look like very good. Final data saving, as it will be performed by the program automatically. You do not have to save by yourself. The program will automatically save it in the respective folder or as CSV file. So here you can see the four files as interval 1, interval 2, result BPS, final result. So BPS2 is BPS CSV, and BPS2 CSV basically based on the average seconds that heart rate calculating is being saved. It's not much concern. The concern is the final data that is showing the low peaks and ventricle and low peaks of the ventricle that we selected. We selected low peaks for the atrium and low peaks for the ventricle because our previously developed role image use this concept for by that data, so we use that concept here. And here you can see that interval 2 is for the AVVA representation that you can see, and cardiac endpoints. This is, I mentioned that interval 2 will show the cardiac endpoints, the result. Similarly, we, for the good validation and the viability of the tool that we developed, we use the heart rate measurement for the Daphnia magna. Daphnia magna is the also aquatic related creation that lived in that environment. So it has only one part chamber as atrium. So you can see here is the part for the cardiac and analytic approaches. We used it. There is no waveform pattern for the two chambers as atrium and ventricle as compared to zebrafish. You can see here the difference in these two aquatic animals. So this is the also concerned about the major part for the validation because it has some kind of variation as the heart rate. Daphnia mostly heart rate contain from 250 above and 300 like something, and in case of temperature it must be from 500 600 like that. So we created three further options for the Daphnia magna for the good approach and for the understanding of the working of the tool. So you can say this is Daphnia normal for the heart rate. Here is the without any toxicity test. Then is the Daphnia 35 temperature effect, and also IMI compound introduced for the dysregulation. These three options separately to check about the working of the program. Selection of the ROI atrium. Here is the data you can see. It's much more than the zebrafish because the zebrafish heart rate is mostly about 200 something like that, between 180 and 200, but here it's more than 300 something. So you have to see that data must be more than that of zebrafish. Here is the single peak for the Daphnia, the same concept for the smoothing applied for hair under the scale of the Daphnia, and you can see here the peaks of the Daphnia magna, the high peaks of atrium and low peaks of atrium. 2000 frame 200 fps recorded video. So you can see it's good for to support the validation as well as also it's good for the understanding that how the program can show the result. So the key features of our program include as there is no need for the video format conversion as compared to ImageJ manual method that always it required AVI format, AVI. So in case of our new approach, there is no need of conversion. You simply directly MP4 video that you record and then you place in the specific folder. The program will be able to run that. No need of any manual calculation that most of the time in ImageJ you have to open the Excel files, Excel sheets, and you have to copy and cut and then paste the data in that field, and then you can analyze, then you the result separately in each sheet. You have time number of time, and in case of bulk of data available, like 30, 60, 90, or 100 fish data. So most of the time for non-expert user and even for the research aspect, in my experience, it creates really confusion, and sometimes data become manipulated unintentionally due to the confusing of the use of Excel sheets. So it's now easy that you do not have to put any manual incorporation in that. Result automatically will be saved in CSV format. You can see automatically, and it will be presented for the further analysis if anyone desired for the any concern. No need to install or incorporate any external plugins. That we use bar plugin for the image. There is no need of any bar plugins. The simply already defined built-in function of the numpy, sumpy, they are performing well for that. They can conclude about the cardiac rhythm analysis in this approach. And in zebrafish, that atrium and ventricle both can be simultaneously detected. That is one of the most significant feature of our newly developed approach. So these are the key features for the OpenCV method based for the cardiac rhythm analysis. And here you can also understand about the concern for AVV interval. We have human also ventricle and atrium chamber, but our heart is four chamber. So zebrafish is most concerned model, animal model that resembles with humans, and most of the studies like toxicity, cardiac analysis, and all that, even in ECG, the most of the animal model as zebrafish being used after mouse or mice. So these are the you can see the ground realities or ground motivation behind this, that we use this approach for the cardiac analysis, and we contribute in the way for the society and betterment in research field to contribute more motivation, and also for the aspect that we can develop future tools with more good viability. Some of the limitations also included in this our approach, that as I mentioned, that ROI cannot be selected by the tool by itself, as well as also the some limitation exist, like some coloring scheme that it's work on the video that is 2D without any color scheme, it's simple grayscale. So these are, you can say, the time taking and also the future perspective that we can include in the future. I hope you will enjoy the tool for the cardiac analysis in zebrafish larva video.